Let me make sure I am sharing sound.
Greetings from Ghana. My name is Steven Arthur and I'm a PhD student on the Peanut Innovation Lab project. I'm studying in Kwame Nkrumah University of Science and Technology in Ghana.
Good morning, I'm David Bergioli. I work with Wild Peanuts and they're the best.
I'm Bodo Abalotov-Sim. I am agronomist and PhD candidate. I work in peanuts breeding program in Seras.
Hello, I'm Mark Hopkins from the University of Georgia here in Athens, Georgia. And I work with Dr. Soraya and David Bergioli in the Wild Peanut Lab. We'd love to have you guys come and visit.
Hello, my name is Sukay Konde. I'm a PhD student. I work with Dr. Fonseca in Peanut at Seras.
Greetings from Athens, Georgia. My name is Nick Magnan, and I'm an agricultural economist working on issues like the groundnut value chain, gender, and information in Ghana.
Hi, I am Professor Ibrahim Ajeju. I am a lecturer at National School of Agriculture of the University of Thiès. I am also co-director of a peanut innovation lab named Optimized Shrub System with Ohio State University. Thank you.
Hello everyone, I bring you greetings from Nampala, Tamale. I am Richard Oteng Frimpong and I'm a co-PI on this project.
Hi, my name is Amanda Davey. I'm with the Ohio State University in Columbus, Ohio, USA. And our peanut project is in
Hello, my name is Rachel. I'm a laboratory technician in Israel, Seras. I'm in charge of genotyping activities by doing systematic quality control in the development of population and verifying the integration of resistant genes from wild to cultivated species. Thank you.
Hello friends, greetings from Uganda, greetings from Namlonge, greetings from us here in the Screen House. My name is Henry Sendagire. I am a master's student in Makerere University. I'm working on a project identifying the alternative host of groundnut rosette virus disease complex with Professor Mike Diom, Dr. Carlo Okello, and I'm being supervised by Dr. Mike Otim, Dr. Mildred Ochosemakula, and Dr. TL Odong. Everything is in process. Thank you.
Okay, so we hope that you enjoyed those introduction videos. And one thing that I want to do just logistically before we get started with today's meetings and welcoming everyone is we are offering simultaneous translation for our meeting. So if you primarily speak French and you would like to hear our keynote speakers and presentations Were y'all able to hear God Love tell y'all instructions in French? You were not? Okay, so I heard God Love, but we do have two wonderful translators here on this call with us. So let me share the instructions with y'all real quick, like just for my screen, and I'll be able to tell you. But there at the bottom of your Zoom controls, there is an interpretation globe. You will click on that, and if you want to enable French translation for this meeting, you will simply click on the French audio channel. And what I'm going to do for you is for just momentarily, I'm going to post those instructions here in French for you to see for our, so you can also have the instructions as to how to join. So thank you to our translators that are working very hard on that. But if you have any problems joining that French channel, feel free to reach out to me via chat and we will be sure to get you connected. So I just wanted to let you know that that service is being offered during this meeting. So without further ado, I am going to turn it over to Jamie.
Hey, good morning, everybody. I'm Jamie Rhodes. I'm the Assistant Director of the Peanut Innovation Lab. I feel like I know most everybody, and like yesterday, I appreciate that we get to have more people via the virtual, but I sure look forward to traveling. So also thanks everybody for sending in videos and for Allison for editing that, because it is nice to feel like we get to zoom around the world a little bit via your videos. So thanks for that. Brief bit of housekeeping. We have a pretty busy schedule today with lots of interesting things that I don't want to waste time listening to me too much, but we are using a Zoom meeting format rather than a webinar format, which means that we can all participate a little easier. But if people can mute your mics when you come on, and I'm not sure how much the video feed interrupts, but if you turn off your video, it might help a bit with bandwidth depending. So that's kind of important things. Today, we're doing some different things. We have 2 keynote speakers just because of the shuffling of our schedule around a little bit. And then we're going to try our first breakout session after the break this afternoon, which we're looking forward to. Yesterday was a really good start to the meeting, and I hope everyone appreciates our slightly different format of having some keynotes and panels, and we look forward to your feedback at the end of the meeting on that compared to our usual just kind of project updates. So I don't waste any more time talking. I would like to just jump in. Our first panel, or excuse me, not panel discussion, but our first keynote speaker. Oh, thank you for the reminder.
We're going to do a quick poll first, just to get us interacting and having fun. So if y'all want to take about 30 or so seconds to answer this question, that'll help launch us right in today's first keynote speaker. Give everyone a little bit more time. I see a lot of people are starting to answer, so this is great. Okay.
Interesting. That one was pretty open. Some of these polls seem like pretty like, oh, I know what the answer is, but this one I was really curious to see the results. So good, pretty even there too. So our poll is very much related to our first keynote speaker. Yesterday we started off with Samara Sterling, who is in our peanut world, but is probably a little bit adjacent to some of the things that we usually do. Not all of us, but nutrition isn't core of our lab. But today we're having someone who is very much outside the peanut world, but we are through a few of our projects starting to touch on remote sensing. And it was an area that we at the ME and a lot of our PIs have been interested in learning more about and thinking more about going into the future, because it really is a lot of exciting emerging technology. And as we asked around through our network, we came across Dr. Greatrex, and forgive me if I say your last name incorrectly, but she has quite an interesting background. She's now an assistant professor at Penn State University. She comes from the UK and was working on lots of work also at Columbia before coming to Penn State, and has a really diverse background, I think, related to remote sensing, looking a lot at rainfall data, but also integrating some social science aspects. And so I'm not going to keep talking, and I will turn it over to Dr. Greatrex.
Thank you, and it is really lovely to be speaking with you all, and thank you so much for the invite. So just to say, if I speak too quickly for you or for the translator, I know there are many languages here and many bandwidths. Just write on chat, let me know. I will keep watching chat and I will slow down. So please let me know if I'm going too quickly. And so I am, in fact, the poll here today was interesting because I am not here, in fact, to talk about weather predictions. I'm not here to talk about the future or forecasts or any of that. And I'm glad, because it's a very difficult topic, and I'm glad that I have a slightly easier topic. I'm here to talk about observations. How do we look at the weather that's happening now? How do we look at the weather that's happening in the past? How do we look at how satellites are useful in that? Next slide, please. And so a little bit about me, just so you know where I'm coming from. And I feel that thank you for the wonderful introduction that much of this has been covered. Oh, the slides have just gone off, so I will carry on talking. So yes, I am an assistant professor at Penn State University. I'm split between the departments of Geography, Statistics, and the Institute for Computational and Data Sciences. The slides have disappeared, but I'll carry on telling you a little bit about my background. My background is in meteorology. And so my background has been in satellite rainfall. How do we use the rainfall and monitor that using satellites? And before that, and since then, I work a lot within the weather insurance industry. I've worked a lot through my job at Columbia University through my job at Columbia University on agricultural impacts, especially on things like groundnut. I worked a lot with CCAS and the CG systems. And really, I explore this relationship between rainfall and humans, how rainfall is used for things like agricultural response or humanitarian response, how rainfall or how the weather might impact health, and how do we observe that? How do we map it? And how do we make it useful? Thank you, the slides are back up now. So a lot of my work is with Met services around the world and in that sort of space. Next slide, please. And so the reason that I'm so excited to be here and speaking with you all is because I get many emails every day or every week from different users, maybe from agriculture, from the humanitarian world, from doctors, from the health world, saying that they want to use rainfall products or they want to use weather products or they want to use remote sensing, but they don't know where to start. Or they compare two products and they're different. And how do you know which one is best? How do you know where to begin? How do you know which one to choose? And so rather than talk to you about sort of the cutting edge science or things like that, I really wanted to focus this talk on you all as an audience to talk about no one talks about what is remote sensing. So what is it? Why are there so many products? Where do they come from? How can you have a voice in designing these things? How do you choose between the 25 different rainfall products? And then what are some of the exciting spaces that we've used that remote sensing in? Next slide, please. So moving on to the next slide. Sorry, I'm not in control of my slides. So apologies if the transitions go a little bit more slowly. We're working as a team. So the first question is that I'm often asked is, are rain gauges enough? Like, why am I bothering to put my whole career into satellite estimation of the weather when we're looking at observations? We're not doing weather forecasts. We're not looking forwards. And so I wanted to start with rain gauges because rain gauges are great. Like, we all know them. You've seen them here. There's a small pot, rainfall falls into it. You know exactly how much rainfall has fallen. Farmers can understand them. You can understand them. They're easy to analyze in Microsoft Excel and other platforms. But there are limitations. The main limitation is that we don't have enough. These are the rain gauges around the world that are used operationally. We have them in real time. Individual countries might have more rain gauges on top of this. For example, In Ethiopia, I believe there are now 1,500 rain gauges. But often it's hard to access them in real time, or you have 1,500 lines of data in Microsoft Excel. It can be hard to analyze them or to use them properly. Equally, we have all been in a situation where we're standing in a field, maybe standing next to a rain gauge, and it is dry. And you look across at the next village or the next area and it's raining over there. It's raining very close to you, but it's dry where you are. Rainfall has a very small spatial scale. Sometimes, especially from thunderstorms or convective rain, especially in the tropics, a rainstorm might only have the spatial scale of 10 kilometers, 10 miles, something like this. So really, if you're going to capture all of the rainfall to be useful across your whole area, you need to have a rain gauge every 10 miles, every 20 miles. Some countries do. Germany, if you see that dark blue, every spot in Germany is less than 10 kilometers from the nearest rain gauge. But most of the world does not. Most of the world, rain gauges are very sparse. And in fact, if you put every single rain gauge in the world in one place, if I was teaching, we would do this as a poll, but the area that would cover, if we put them in one place, is less than a football pitch, less than a soccer pitch for the Americans in the room. We're not capturing that much area with rain gauges. And so satellites can help us fill in the gaps. Satellites are able to see the whole globe in some cases, or certain areas. They're able to see larger areas. They're able to take images that go back in time that are very regular. They're tamper-proof. You don't have to worry about trees and placements. And so satellites and rain gauges together are great. Next slide, please. And many people are starting to use satellites and remote sensing in groundnut research, in peanut research, in operations, in extension. For example, the University of Reading, PICSA, their Participatory Integrated Climate Services for Agriculture program. In some countries, in Rwanda, for example, they are using satellites instead of rain gauges when they're looking at extension. And they're working on ways for communication around that. Plant Village is doing the same. Insurance is now spreading across many farmers around the world. Many more farmers have access. And many insurance programs are using satellites. They're using remote sensing. Equally, in research, in crop modeling, in looking at climate change impacts, at looking at things like post-harvest losses, people are also starting to use satellites, whether that's to look at vegetation or look at the weather or looking at something else. So people are using these things. And then the job is, how do we use them well? How do we use them better? Next slide, please. And as I said, it is overwhelming. So you're like, great, I'm working in an area with no rain gauges, or there's one rain gauge and it's hard to access and I've lost the data. I'll use satellites. And then you're like, great, I need rainfall. I'll use satellite rainfall. And then you go and look and you find that there are 30 different rainfall products just for your area alone. And some of them have different resolutions. They have different latencies, like you can't access some of them immediately. They have different spatial areas. And they also look different, like they are different things. So for example, on the top right, this is the rainfall estimates for different products, different satellite rainfall products on the same day in July, I believe, for West Africa. And you can see, even from a distance, they look very different. And this should rightly worry many of you. Is like, if you used RFE2, like, well, maybe this one is correct. Maybe there was heavy rainfall here and you've missed it. Or maybe this has a better spatial distribution of rainfall. And even with rain gauges, we don't know that much information because the gauges can be quite sparse. So this might, even the rain gauge maps might not be correct. So you reach out to a meteorologist and they send you something like this down here on the bottom right. They send you something like these scatter plots and are like, well, this scatter plot looks best. Use this one. So let's see if we can do it better. To start doing it better, we first need to understand Where do remote sensing products come from, and why do we have this diversity? So that's where I'm going to begin now. So next slide, please. And the first thing I want to stress is that people often think about satellites and remote sensing, things like that, as a black box or as magic or as science, and these things just come out and you get these products. But I just want to stress, all we're doing when we use remote sensing, when we take satellite images, we're taking photographs. Like you take photographs with your camera, video camera, things like that. There are many, many satellites in the sky. On the left, you can see the current Earth observing network. I think there are almost 100 satellites just for Earth observation, for weather and supporting people like us. There are over 100 satellites in space, all just taking photographs. But those photographs might have different wavelengths, which we'll cover, different resolutions and different properties. So the products that you download, the products that you use, they're literally just combinations of different photographs at these different wavelengths and different resolutions. And from that, we try and guess what's happening on the ground, whether that's rainfall or greenness or phenology or something like that. But thinking of them as photos helps to put them in more context. Next, please. So let's start with rate wavelength, because this is one of the most important things about remote sensing. So light that we see, a light around us, has different energies, and we know this. So high energy light has a short wavelength, and that's gamma rays and X-rays, all the way down to low energy light, through visible light with the rainbow that we see, through infrared, microwaves, and radio waves have very low energy, very long wavelengths. And we already know this. We already take images at different wavelengths of light. For example, X-rays are taken using wavelengths of X-rays. We take photos in visible. Every time someone takes your temperature using one of the devices, they're using infrared light. Importantly, if you take a photograph of the same thing using different wavelengths of light, you get different information. And for example, this is the same place in space, the same nebula as a galaxy, I think, using different wavelengths of light. You can see very different information because that tells you something about the physical properties of what's going on. And so for agriculture, this is also what we're doing. We're trying to identify the correct wavelengths of light that are useful to tell us what's going on. Next slide, please. So taking photographs at different wavelengths of light can identify different things. And that's especially because in the Earth, because here on Earth, the atmosphere itself and different things some things will absorb different wavelengths of light, some things will reflect different wavelengths of light. And so we can use what we know about physics to tell us what we're looking at. So for example, we know that the sun releases a lot of visible light. That's why we see invisible. That's why our eyes are conditioned to this, because the sun uses visible light in this little rainbow area. And so when we take photos in the visible, we see what the eye would see. But the Earth releases infrared light, and that's heat, that's energy. So essentially, if we look at a photo in the infrared, we can tell something about temperature. So here, the whiter areas are cold, the darker areas are hot. And we can use this to detect clouds. Clouds are very cold, they're high up. So we can start to use infrared for cloud detection. More specifically, we know that different parts of water will interact very specifically with different energies of light. And this allows us to tell the difference between liquid water and ice. So we can look at what proportion of the cloud is made of water drops versus ice droplets, so we can tell something about the energy. And combining these images is how everything works with remote sensing. This is all we're doing. For example, many of you will have used NDVI or greenness or EVI or vegetation remote sensing. All NDVI is doing is that we know that vegetation will reflect heat, it reflects infrared light, but it absorbs red light. That's why plants look green, they absorb red light. And so if you look at the difference between infrared light and red visible light, you can detect vegetation. So this is all we're doing with remote sensing. Next, please. And because of this, people are like, we should put stuff in space. We should take as many photos as we can. And so actually, there are even different cameras on the same satellite. So out of all of these 100 satellites, for example, here is one. This one satellite might have 20 different cameras taking photos at different resolutions, different wavelengths of light. So we have an overwhelming amount of information that we could use. Next. Next slide, please. And also, we have a load of different types of camera and a load of different types of orbit. So for example, some satellites, some cameras are geostationary. They are very far away from the Earth, so that when they orbit at the top, you can see they're always looking at the same point. They always look at the same point on the Earth's surface. And this means they always look at the same area of the globe. So we can take photos all the time, see the same area of the globe. In fact, that's how we do a lot of weather monitoring. We look at the same area, we see the clouds bubble up, we take photos every 5 minutes. But these satellites are very expensive, they're very far away, they're quite old. We have low spatial resolution, the cameras aren't very good. So we might only be able to see a grainy, a coarse image of say 5 kilometers or 10 kilometers. We can't see the detail. Closer in, we have satellites which are polar orbiting or low Earth orbiting. There are more of these, they're cheaper, and you can really zoom in. It's high spatial resolution, sometimes even 10 meters. You can see individual things. It's how the military works. But they don't see the whole globe at once because they're very close and they're zooming around. So maybe you'll only see one area once a week. And so, for example, cloud liquid water vapor on the right, you can see there are some areas of the Earth that we just didn't see this time. So we have now an even more complexity, different wavelengths, different types of images, different resolutions. Okay, next, please. And so when we say we're creating a satellite product, like rainfall products or like greenness products or phenology or forest fire products, this is what we're doing. First off, we want to work with specific experts to understand the topic. What physical properties does the thing you care about have? How would you take photographs of it using a camera or from a drone? How would you detect what it looks like in the field? How does it look? How could we take photographs and find out what this is? And so this is why it's so important to work with subject-specific experts like yourselves. Secondly, we work with physicists to understand mathematically which wavelengths of light could help us detect these things and which resolutions we need and which combination we need. And we make a mathematical equation, an algorithm, to combine all of these photographs into one single image, which will tell us about what we want to know. This can be very complicated. For example, on the right, you can see all of the different images, all of the different photographs that go into the forest fire product, which looks at fire, and you can see the huge complexity of what goes on. Many are from different satellites, so there's not just one satellite. We then get the data, and then we validate in specific places. We then test to see, is this any good? Could we tweak it? Could we change it? So the first thing to be aware of is that there is no one satellite. There is no, for people who use rainfall, say chirps, there is no chirp satellite floating around, or there is no NDVI satellite. We're using images from many places and combining them. Next, please. And also, this starts to answer one of our big questions. Why are there so many products? Why are there so many guesses of rainfall? That's because they are guesses. There are many attempts at working out what rainfall on the ground or what vegetation or phenology or forest fire might look like using photographs. And so each product is a different attempt. Different products might use a different equation, a different algorithm. They might use different cameras or different data sources. They might have different resolutions. Some might be very coarse or some might be fine, or different timescales. And so there is no perfect one. And people often want me to tell them, what is the perfect product? Please, could you just tell me the product I should use? And sadly, the answer is that you need to choose, and you need to choose the best one for your needs specifically. For example, the best product for detecting drought in Colombia, it might be different to the best product for detecting drought in India, because the geography is different and the rainfall is different, and you need a different algorithm or a different set of data sources. So there might not be one best product for detecting drought. It might depend on geography. Equally, in the same place, the best rainfall algorithm for detecting high rainfall or floods, it might be different to the best one for detecting dry spells. So you might find that the topic is also important. The exciting thing about this is there's space for custom products. If you can articulate, if you can explain what you need, then satellite remote sensing experts can help you co-design a product that works specifically for you. And this is really where the future is. It's like, how do we make custom products? Next, please. So now I want to quickly talk about some common features of satellite rainfall and move on to satellite rainfall, because this is where my background is, and I want to share some of the rules of thumb that I use when I'm choosing these things. As we said, there are many different products you could use. How do we choose? So let's move on to the next slide, please. The first thing to know is that even though there are many different products, there are families, and those families use different data sources. For example, this is the infrared family, Kristen, if you could click on the orange picture, I think it might start playing. Oh no, don't worry, we'll leave it at that. But basically, what they'll do is, what infrared does is it looks at this temperature data and it looks at the height of a thunderstorm, and it says these thunderstorms are very cold, therefore it must be raining. This temperature is cold, so it must be a very tall cloud, therefore it must be a thunderstorm, therefore we should get rain. And what you do is you just add up this time where you have tall clouds, and you keep adding it up into something called cold cloud duration, and we link that to rainfall. These products have been around for a long time, maybe 35 years. It's a long time series. You're looking at CHIRPS, ARC2, TAMSAT, ENACTS. These have a coarse spatial resolution, maybe 10 kilometers, maybe even 5 kilometers or higher. Some use rain gauges. They're really good for trends, but sometimes they can be fooled. And they will be fooled in areas where rainfall doesn't come from thunderstorms. If you have a lot of high cloud, a lot of cirrus with no rain, the satellite might get confused, because it's, if you look at case C and case D, you can see that there is no rain, but it's too cold, it's above the threshold. Also, we can miss extreme rainfall because this is quite a simple approach. So it has usefulness, but it has limitations. Next slide, please. There are more complicated products now that use more families, that use infrared and rain gauges, and they might use things like microwaves, which can tell us how much ice is in a cloud or how energetic it is. Sometimes they use flashes of light with lightning. Sometimes they use an onboard radar to try and improve things. These tend to be more recent. There's a less long time series. They can have different, they're more diverse. And so it's harder to say, are they good or bad? In some places they'll be very good, and for some applications, and in some applications they work less well. But you can see that these different families start to emerge. Next slide, please. Also, an important rule of thumb that is not really to do with satellites, but is really, really important for you all to know, is to remember that satellites are not replacing rain gauges. They do not look at a point, a single area. They do not look at a single location. They look at an area. So for example, this is a 10-kilometer area on the left over my home, well, over the town I live in, State College. And you can see there's the town in the north, there's some forest in the south. Let's say our area has 5 rain gauges. We're not looking at satellites. And here in the middle, we have the time series. So we can see on day 1, it was dry. There was no rainfall. All of the rain gauges said dry. And now let's look at the average. No rain. It was dry. It was 0. Day 2, there was a rainstorm, but it only really got to the forest. Like this happens all the time. Like the hills get rain, but the town stays dry. And so you can see it was raining pretty heavily up in the hills on day 2, gauge A and B, but it was dry in the rest. So the average, there's a little bit of rain, but it's averaging out dry and wet, so only a little bit. Day 3 was quite wet. If you look over the time series, you see that every individual rain gauge has lots of high values, lots of extremes, and lots of zeros. And this is often how we think about crop input or things like that. We think of an average field, a specific place. And so, but when you look at the average over a 10-kilometer area, you see that there's less extremes, there's less very high numbers, and there's less zeros. And so you can see this on the right with real rain gauge data in Ethiopia. And you can see each of these gray lines is the individual rain gauges, and then the red line is the average. So this is, next slide, please. This is really important because if you care about dry spell lengths and you're looking at the average and all satellites are looking at an average, your dry spell lengths will be different, they'll be altered. If you talk about seasonal start dates of 3+ days and more than 20 millimeters of rain, that will be different using a satellite. If your crop models are often calibrated using gauges. So you need to maybe rethink your statistic, or you need to adjust the satellite to take this into account. So this is not really to do with satellites, but it's to do with averages and spatial averages. And it's important to bear in mind. Next, please. Also, people often think about satellites as direct replacements for rain gauges. We just look at a single point, we just get a time series out. Satellites aren't very good at that, but you've seen that they're very different. And knowing the exact rainfall in Tambacounda at the 20th of July is difficult for a satellite to know, but they're very good at the big picture. If you zoom out a bit, and so for example, here is looking at the rainfall across all of Senegal, and each window, and there are some people in the audience who will know this plot, and each window is looking at, is it wetter than average using the satellite or drier than average in the end of June to the end of July. It's looking at July rainfall. And you can see that there are these features. You can see 2002 was obviously very dry, especially around Kusnar and that sort of area where we were looking at insurance with the R4, WFP R4. You can see 2005 down here on the second row is quite wet. You can see that 2014, it was dry in the west, but wetter in the east. So you can pick out some of these things, and you can pick out these larger scale things, even if you don't know the exact rainfall at an individual location. So thinking about zooming out a little bit is sometimes useful. Okay, next slide, please. So then practically, how do you do this? Because it's all well and good knowing more about it, but literally what steps should you take if you want to do this yourself? So here's my guide that I email people to, like, how should you choose your best product? So next slide, please. So the first thing is, don't start with how good it is. Start with the metadata. Start with things like, how long is the record? What pixel resolution do you need? Do you need daily data, monthly data, 3-hourly data? Do you need the data immediately, like real time? Can you wait 5 days? Can you wait 6 weeks? Because then you have different products available to you. Are you doing this in Africa? Are you doing this in Bermuda? What you can do is start with your practical requirements. Take these big lists. For example, I'll send these slides out, but the IPDWG database has these big lists, and you can then make a subset of the products that might actually be relevant to you. There's no point knowing that, say, trim is better in your area if TRIM has stopped producing estimates and you need real-time data. So start with practicalities and use that to zoom in. Next, please. Secondly, focus on the aspect of whether you care about. Don't just look at totals. Focus on what you care about, whether that's leaf area index from a crop model, soil moisture, dry spells, aflatoxin rates, whatever it is. And if you just click next, it should pop up. Thank you. And that's important because let's say we validated the satellite rainfall estimate on monthly rainfalls, on rainfall totals. We know that for groundnut, especially for peanuts, the total rainfall amount is the least interesting thing about rainfall. So for example, in India, between 1975 and 1975 and then 1981, the total rainfall that fell in Andhra Pradesh was identical, both or 400 millimeters. But the crop yield, the groundnut yield was very different. And obviously this is because in 1975, the rainfall had a good distribution. In 1981, there was a big dry spell during flowering that you got bad crop yield. So when you're thinking about asking questions about which product do you need, in this case, you might want to think about which product captures dry spells better, rather than looking at rainfall totals. And also thinking about your particular place. Best product in Iowa is maybe not the best product in Senegal. Next, please. And also see what already exists and make maps. Look at Google Scholar for existing studies, existing validations, see what people have done before, see what you can access on these different web portals or viewers. And importantly, look at the data, play with it and make maps. So for example, if you press next, then what we have is here you can see, this is the average rain per rain day for one product. And you can see that even though at the validation sites at the rain gauges, which are these little dots, you had high average rainfall, the algorithm that created it was not very good. And when you went away from a rain gauge, actually the product completely changed. So if you'd have just looked at those scatter plots, you would have missed this. And if you were using this for ag extension, you might have given farmers the wrong information. So make maps, explore your data. Next, please. And don't be afraid of common sense approaches. Don't be afraid of talking to people and asking them. So for example, these are two different products. We have the season normally product 1 and product 2. This is in Somalia. I'm not sharing their names because again, it's context specific. And this is looking at the time series of them. So each month we have going across the bottom and going across the left-hand side is the year. So for example, the bottom row is looking at 1983, the rainfall, and the color is how much rain fell. And you can see that we know from talking to people that the season starts in mid-October in this area in Somalia. November's late, but people normally start planting around October 20th in a good year. And so you can see that product 1, that story kind of makes sense. You can kind of see this variation. Sometimes it's early, sometimes it's late. It's around mid-October. Product 2, however, looks like there are some clouds before the season starts, and the product 2 thinks that those clouds are raining and it's getting the season start date wrong. So we're not doing anything fancy here. Just looking at common sense approaches can often help you. So finally, and I won't go into them in detail, I want to just show you 4 applications, and when we send out the slides, they're just there for you and for your background. So if we go through them very quickly one by one, and we'll finish on the conclusions. So next slide, please. Okay, so and next again. So if you're interested in trends, people have done work on trends and climate change and things like that using satellites. They have done work on how to use seasonal start dates in a way that works better for satellites than just looking at individual statistics like number of rain days or something like that. This work is out there and I can link you to it if you're interested in climate change, historical trends, wetter or drier, etc. Next. Crop modeling. This was my PhD. If you're interested in how crop models, how you use a satellite with crop models and the non-linear uncertainty with that, how do you put uncertainty into that, then absolutely we can talk about this. So it is possible to run a crop model like DSAT things like that using a satellite, but you have to think carefully. Next, please. Agricultural insurance was my life for a few years, as a few other people in the audience. Many people are now using things like satellite rainfall, soil moisture, different policies. And again, you have to think very carefully about these things. So for example, you can see that rather than looking at a map of rainfall in the bottom right, I was looking at a map of whether the insurance product would have paid out based on satellite rainfall, looking at payouts. And you can see in 1996, in the top plot, you can see that there's a lot of areas of blue where the satellite rainfall said there should be full payout, full compensation, but one pixel that's white, 1 10-kilometer area with zero money. So are we really telling farmers that if you walk 10 kilometers south that there's no drought and you shouldn't get money, or 10 kilometers north? Maybe there was a mountain there. Maybe though the satellite needed adjusting. So if you're interested in insurance, let me know. And then finally, next slide, things are now getting more complicated. We're now combining satellites in new and interesting ways. For example, using rainfall to support things like soil moisture, monitoring, we're using soil moisture satellites. So we're now moving beyond just rainfall analysis to make some of these more interesting operational products. And again, if looking at things like that is interesting, I can link you to the appropriate people. Okay, final slide. To summarize, there are no perfect satellite products. We are guessing. We take photographs from space and we try and assume something about the world that we live in, whether that's greenness or rainfall or ice and clouds or sea surface temperatures. They are estimates. Just in the same way that a rain gauge is an estimate, like we only know rainfall at this one point, not 3 fields away. But many satellites do have common features or common families, and understanding them a little bit and reading about them a little bit can help you choose what the best thing for you. There are some really interesting new applications coming out that are using this, but again, each one will need to be custom tailored for that application, and so thinking through that. And there's space to go the other way. There's space for custom products. If you are like, we need to know this, and this is how I think we could observe it using cameras in fields and things like that, maybe we can observe it from space and make a product for you. And this is what people like Media Lab and NASA are asking for. So there's this space for co-designing custom products, if that's useful. Thank you for your time, and I will see if there are questions, or if not, then I can answer them by email.
Can I ask a question, quick question? J.S. Wong from University of Georgia. It's a very interesting topic. I know there's a lot of applications, including in UGA had a strong program in using those data. The only question you see, looks like all those data you presented is retrospective. 70s, 80s, even the earliest is 2013. How this technology can be used for prediction, or can really on-site or timely, like can instruct in the agriculture. That's I think much more important for those developing countries, because farmers rely on their harvest or their products for their living. Oh, you're mute.
That is a great question. So basically, there are spaces where they intersect. The one place where they intersect is that rainfall, some variables like soil moisture do have more memory. And so putting the rainfall into a soil moisture model, for example, we know if the soil is very dry, doesn't matter if it's the wettest year of all time, the soil might only get to average, so you can kind of predict within season. But the other place where it's more useful and maybe more used behind the scenes is all of these weather models you use, all of these different numerical models for predictions. We're learning how to put satellite data into them to help them improve their models. And I'm currently on the PhD committee of Joseph Chan, who is working out what are the best aspects, what are the best photographs to use from space that could help the models get better? And so the answer is that behind the scenes, these products are useful in making the models better, but we're working on that. But the other space is that sometimes knowing high quality information within the seed, like if you know that it didn't rain during flowering or that the soil is very dry during flowering, you do have some predictive power within that. But really, a lot of the applications I work on are in that space. So for example, if we know it's heavy rainfall now, we know that more children are going to get the disease hydrocephalus. And so we can use the monitoring to help in the decision making. But I agree, the prediction is incredibly important, and maybe you need to have extra speakers to talk about it.
Thank you.
Thank you so much for the presentation. Really thoughtful and thought-provoking. I was going through a lot of potential, applications. We have projects looking at planting date, for example, or timing, harvest timing related to aflatoxin that could be useful, looking at those trends, and really useful, kind of helped me with some of my assumptions that I didn't know that much about how these things work. And the next time I'm getting ready to yell at my dark sky app that it's going to rain when I didn't think it was going to, I'll think a little bit more about where that data came from. I think we have time for maybe one more question. I know there are a few in the chat, but I know our timeline is pretty tight. So
well, if you want,
yep.
So I can answer the question about the
Sure.
data in the chat afterwards, because there is some R code that I can share, so I can work with people who are interested. And I know other people in this room also have some of that R code. But there is a question about climate change, and how does climate change influence the use of older satellite trends regarding their reliability to predict trends? That's a great question. It's not so much about climate change as too much cameras change over time. And so like for example, Meteosat is the satellite that looks over Africa, but there have been many Meteosats. We're on Meteosat 12, and each one the camera changes and things like that. And so some products are very good at being consistent and making sure that that doesn't affect the changes, and things like Tamsat work very hard on becoming a climate change trend type product. Other products can struggle sometimes, and then they might say it's getting dry, but really what they mean is that there are less rain gauges or the camera changed. And so in terms of climate trends, that paper that I showed, and I'll put in the chat, talks a lot in detail about that exact question. How do you pull apart climate change versus how do you pull apart the differences in the observing record? But it's a surprisingly complicated topic that's really, really interesting to dig into.
Excellent. Well, in the name of time, I'll say if there are additional questions, to certainly direct them in the chat and reach out. And thank you very much for the presentation and coming on and sort of tackling our peanut interests from outside a little bit. I thank you. To shift gears a little bit, I will ask Kristen to launch our next poll. I have a few seconds here to answer. Wait a few more seconds while folks get on, and interesting. All right. A lot of interest in this area. I'll be managing our groundnut seed breakout room, so I look forward to meeting with a bunch of you related to that later today too. And with that, we'll introduce our next speaker, Jeremy Venable. Jeremy is has been working with us. Gosh, it's been, I think, 5 years, maybe a bit more. Jeremy's been in Malawi working with the USAID Malawi funded project called AgDiv, working on diversification of agricultural activities in Malawi, which is of course also one of our target countries where the Innovation Lab has been working for some time. And it's been a really great experience to work with AgDiv and thinking through some of USAID's priorities on how we scale out our work, and also the great opportunity that we have within the Innovation Lab to carry some of our expertise over and learn back from the development process. And Jeremy's going to talk about that, but also some of the challenges with how these things work. And it's something that we would like to think about moving forward within the Innovation Lab, about how do we best do that moving forward, connecting with missions, because it's really important for us to remain extremely relevant and our research to be relevant to the missions, and also to support their activities and integrate as best we can. So Jeremy has 10+ years of experience in ag development. He's worked on a lot of commercialization with smallholder farmers. Previously, I know he worked in Ghana for quite some time, which I'll pick his brain on occasion with things when we're chatting on Ghana related projects as well, because he's got some time there on the ground in northern Ghana. And but also within the our work with him, I know he works a lot with other innovation labs and research partners, universities, all kinds of different private sector players on the ground as well. And so he's really become our point person on our work with AgDiv, which I'll just say has both Innovation Lab core funded projects, but also we have some funds from AgDiv that we work pretty collaboratively, even on students, which I think has been a real example to some of the other innovation labs and ways forward for us to work in the future. So with that, I'll turn it over to you, Jeremy, and look forward to hearing your talk.
Good, thanks, Jamie. And so as Jamie mentioned, I'm going to talk a little bit about the partnership that the AgDiv project has set up with the Peanut Innovation Lab. We're maybe a little early to talk about lessons learned. This is definitely something we've been spending a lot of time thinking and talking about, is kind of how do we replicate this, or how could we make this better in a different iteration or in a different location with a different lab or a different partner. So what I'm going to talk about today is kind of two key concepts that I think allowed this partnership to be successful. Hopefully we'll have a little bit of time for questions afterwards. And then this is also the topic of a breakout session that we'll be doing both today and tomorrow. Next slide. So as Jamie mentioned, I work for the USAID Malawi Feed the Future Ag Diversification Activity, also known as AgDiv. We got an extension, so we're entering our 6th year of implementation. And there was kind of two unique items about this project from the very beginning. One was collaboration with USAID programs in country, including the innovation labs, was specifically laid out by the USAID Malawi mission. They're kind of in a situation that they had a lot of USAID projects happening, and they were having a hard time making sure that they were coordinated. So they made one of the roles of this project to be that coordination. The other activity, which might not be as unfamiliar for USAID projects in a place like Ghana, was they put an emphasis on integration with the private sector as well. Malawi, as one of the poorest countries in the world, had largely been receiving USAID humanitarian funding, so that changed the type of programming that they were able to do here. But this funding targeted private sector integration. And also, real quick, a little bit of background about myself. I'm the Director of Strategic Partnerships for this project, and so I'm responsible for that USAID integration and that private sector integration. And our work with the innovation labs has really crossed over those two areas well together. as Jamie mentioned, I worked and lived for 5 years in Ghana, most of the time in Tamale. I've also lived and worked in Guyana for a little bit, and now I've been in Malawi for about 5 years. So I have kind of been following the peanut lab around a little bit. Next slide. So this is just the project's results framework. We'll see that outcome 5 is key, and that's kind of that outcome that USAID designed to allow us to do that integration activity. But I think it's important to note that our work with the Peanut Innovation Lab has covered outcome 1 through 4 as well. One of the topics that I'll come back to a lot in this presentation is the depth of knowledge, expertise, skills that we're able to draw on from the Peanut Innovation Lab and their network. So kind of whatever question we came to them with under one of these outcomes, or even something not on this page, we were generally able to have a conversation, have a discussion, and find a way that we could work together and move forward to solve that, so answer that question. Next slide. This is again one of the, I can call it one of kind of the AgDiv standard slides or standard operating procedures. And it covers all of the activities we do underneath the project. But again, is very relevant to the work that we've done with the Innovation Lab. And it kind of fits into some of the discussions we were having yesterday about how do you fit research into cultural practices or into local country context. You know, I think the key thing here has been that holism. Again, we are able to, any question along the groundnut or the peanut value chain, we could go to the Innovation Lab to help think about that. So we could offer partners that we are working with a bundle of knowledge or a bundle of interventions that we could do to reach our goals. Next slide. This is again kind of a similar slide, and I think it made me think about the slide that, or the document that David Jordan yesterday posted into the chat, talking about kind of how he looks at research topics with his class. You know, he brought out define, use, and verify as the first steps. And that's really what we've been working off of as well, and integrating with the Innovation Lab. And I think this also, again, looking back to yesterday, brings in the social science aspect. You know, as a project, we're not a research project. We're an implementing partner and a specific USAID funded project that has our own targets. So we probably more often start on the social science side of things, and our relationship with Innovation Labs allowed us then to bring in that ag, or more specific ag or hard research to address these activities. But you know, key activities, we had to go through and analyze what we needed to do. The Innovation Lab team was very helpful on that. Next step, identifying those key constraints. And then I think what we'll talk about most during this presentation is that third point, that collaborative CLA, collaboration, learning, and adapting, that we use to design interventions that really fit the market and the system that we are working in here. Next slide, please. And so the two concepts that we're going to talk about today is expanding the market for research, and then matching market research to those matching research outputs to those market needs. And that's really, I think, how we've been able to increase adoption by smallholders of key technologies, especially key technologies that have been part of the USAID Innovation Lab network. And then we've really just helped them take it to market. And I really think that's kind of the core of how this relationship started. and what the big impact was, is we are able to, at the very beginning, we needed the technologies and innovations that would increase yields and increase resilience for smallholder farmers. We were able to work with the innovation lab to identify those. And then it was really about how do we get those out to the market. Next slide. And so that's where we'll start. We'll start with expanding that market for research. And again, thinking about the conversations that are happening in the chat and in the question Q&A yesterday, they really revolved around who the research was for, who are going to be the beneficiaries of the research, and how do we get to that point? How do we identify that, and how do we make sure it's the research that's needed? So I'm going to talk about a little bit of our context, in kind of the key markets that we identified and then have been working with here. I think this also has some overlap with the product lifecycle conversation that will be coming up later and is part of the USAID Innovation Lab movement at the moment. So next slide. But one thing I wanted to touch on first is the rest of this presentation might seem a little bit odd or a little bit different for most of the audience today. It's not about doing core research. It's kind of how you present that research. But in order to present something, you need to have something. So really everything that we talk about moving forward is based upon doing research. It's based upon national research programs here in Malawi. That's the NARS, the Department of Agricultural Research Services. It's the Agricultural University. And then with the Innovation Lab, it's the US-based researchers, it's the regional researchers, it's the US peanut industry as well, bringing that private sector over to Malawi also. And so having that base of research is what makes the rest of this possible. And that was really also, again, kind of some of the early discussions that we had with the innovation labs. They made it very clear at the beginning that we still need to have this research. That's our starting point. And then, moving forward, thinking 5 years later, the message that we're giving to our partners on this side is we've made a lot of progress in the last 4 years, but there's still a lot more of this research that needs to happen. So really the system doesn't change. It's just kind of how that system is presented outwards. And so that's kind of actually going to be the second part, again, that research outputs. The next slide. So here in Malawi, we identified kind of 3 key markets for the research that we are doing with the Peanut Innovation Lab. The first one was actually the USAID mission or donors and other NGO partners. That was really key. As we mentioned earlier, private sector was key for this relationship and the work that we've been doing. And then, of course, ultimately, smallholder farmers. And that one is really focused on how do we deliver this research to farmers. So the next slide. So this one maybe seems a little odd. I work for a USAID project. The Innovation Lab gets its funding from a USAID, Why would we need to market their market research back to USAID? And I think there's kind of 2 main points. So one is that when you're in a country and you're working in this development space, you can think of USAID as a decision maker. They're the people looking at funding, they're the people designing programs, and so they're very key on making sure that they understand their research. But a lot of times they kind of assume that basic research has already been accomplished. You quite often in the development space, people are asking for the next exciting thing, or they're looking for a silver bullet. And they kind of assume that all the kind of the regular questions around agronomy have been answered in a general context or in a very local context. So it's hard to get them, it's hard to have a communal starting point when you're talking about what sort of research is needed. And I think another important concept to note is that people in USAID or a donor agency or an NGO working on agricultural programs might not be an agriculturalist. They probably do not have a degree in plant science or agronomy. So they're not a specialist, they're a generalist, and that causes them to easily miss kind of key points. And unfortunately, when working with a crop like groundnuts, it's different enough from maize, it's different enough from even other legumes that leads to knowledge gaps, and then that leads to poor decisions in funding or in policy. So it's really important that research is designed to address the needs of donors and to speak their language. And so if you can go to the next slide. So this is, I'm going to kind of talk about some of these partners or these markets in the context of some case studies that demonstrate a little bit of what I'm talking about. And so in Malawi, with donors, I'm going to talk about inoculants. So we're probably all familiar with inoculants on this call. And in Malawi, it had a large amount of support from the donor community. They really saw it as an appropriate technology for small scale farmers. USAID, UK funding, all the large donors supported inoculant. The example I'm going to use is from a UK funded project here that was very instrumental in getting inoculant to market here. They worked with DARS to design the first Malawi, or to develop the first Malawi specific strains, set up the first production line at the DARS station. They got it approved by the ministry. They got commercial partners to adopt it and start producing it as well. But when talking with the team leader for that project, it became clear that they did not know how inoculant worked. And after talking with him, I started asking other donor partners and other implementers about inoculants. And the general understanding was that inoculant, not only does it replace the need for applying fertilizer to legume crops, it actually puts nitrogen directly into the soil. That was the understanding. So they had missed kind of the basics of inoculants and nitrogen fixation. And you can see kind of, okay, that's not much of an issue, but you start thinking, well, how does that affect adoption by farmers? Or how does that affect how you talk to farmers about using inoculants? And how does that sync with cultural practices? So in Malawi and a lot of other places, legume crops, it's usually a complete removal of biomass from the field. So here, both on soybeans and on groundnuts, when they're harvested, the entire plant is removed from the field. A crop like groundnuts, with a large amount of the biomass underground, that's being removed. And so none of the leaves, in some cases, none of the roots, none of the above ground biomass is being kept into the soil. So you do lose that next year's effect of an increase in nitrogen in the soil. But a lot of the messaging was around legume crop rotation with the use of inoculant will increase nitrogen in the soil, increase organic matter in the soil. But cultural practices does not meet with that, and the people promoting inoculant didn't understand that there was this mix match there. You know, in this case, the project worked well, it accomplished a lot, but you know, a lot of times these sort of you know, differences in understanding or knowledge gaps could lead to poor performance or poor adoption moving forward. Next slide, please. The other one that we worked closely with is adapting research to private sector. So I'm going to take a little bit of time to talk about what private sector meant for us and kind of the Malawi context. We really were working with and working for partners that were willing to make co-investments into the research as well as into the end product that went to farmers. You know, they were really co-investors in the activity, and more importantly, they were consumers of the research. So in Malawi, the group that we've worked most closely with in conjunction with the Peanut Lab team are several diversifying tobacco companies. And we can see a picture of that diversification. Those are tobacco drying barns that are now drying groundnut seed in them. And so they are making investments both as companies, but also for their farmers to find crops that help support these farmers that they've been working with on contract for tobacco to increase their farm income through non-tobacco crops as tobacco demand declines globally, but also just to make sure that the farmers they're working with have a more robust crop cycle on their land. And very important to this collaboration is kind of their demand for research products. This was based on themselves doing a lot of tobacco R&D over the years. In Malawi, most of the tobacco is grown under contract in integrated production systems where farmers receive inputs on credit, extension services, and then obviously the offtake in the market. And they really wanted to replicate that system for groundnuts because they had seen over the previous 15 years that they took tobacco yields from 700 kg a hectare to above 3 tons a hectare. So they really knew that investment into research, investment into extension pays off for the company and most importantly pays off for the farmers. But kind of the first roadblock that we ran into was this need for translation. And I think this is really important to keep in mind as we go forward in this presentation and this discussion is how do you present research to different partners? You know, these guys quite often came, tell us what to do. And Innovation Lab guys said, we need to do research to answer that question. And so there was a big role that I played and the project played in kind of translating what's needed, what's possible, and how do we get that kind of shared understanding. So you can go to the next slide, sorry. And so this is where I think, this is kind of a little bit of the case study here, is that with the innovation labs, we are able to combine knowledge and combine expertise. Again, these tobacco companies said, we only know how to grow tobacco, but they were agronomists. So they really knew, they knew the basics of growing crops here in Malawi. They knew the basis of working with farmers, but they didn't kind of know how to make that steps. They didn't have the familiarity with groundnuts. And so the Peanut Innovation Lab served as our knowledge base, you know, both broadly on groundnuts and, you know, very detailed questions that we might have had. We are able to have those discussions with the Innovation Lab and most importantly, again, their network. Pre-COVID, you know, there was always several trips a year where the Innovation Lab would come out, both the management entity as well as core researchers, and core partners from the US peanut industry, as well as the regional industry, that when we needed to talk about setting up seed production, even early generation seed production, you know, we could bring in seed experts with them. When it was processing, we brought in processing experts. So again, this is a very clear example where working with the Innovation Lab allowed us to offer research and research products to our partners that were exactly what they were needed and what they requested. If we can go to the next slide, please. And I think a good example of this, which I think a lot of you are aware of, is the Georgia Peanut Tour. So actually, even before this project got started, there were groups from Malawi going to the Georgia Peanut Tour, and we continued that. And I think that has really had one of the largest impacts on this project, on this collaboration, is being able to take our partners here, and that included the private sector, it included the national program, it included USAID representatives, to take them to Georgia and really show them what the potential for a peanut industry is. And it really became what we modeled a lot of our work and our activity on. You know, so this picture is Justus Chintu, who many of you know as the breeder for Malawi. It's Dr. Grace Kaudzu, who's the head of the Seed Services Unit in Malawi, and it's Dr. Elizabeth Sabali, who's the Deputy Chief of Party for the AgDiv project, and also a plant breeder by training and experience. And so, you know, being able to take that core of knowledge from Malawi over to Georgia, have them do the tour, combine it with additional visits to the University of Georgia and other key partners has really been key. And I really don't think without that activity, we would be where we are today in Malawi, because we've got, you know, we're having conversations about how do you manage seed development, foundation seed quality control and management, which is, this picture again is from the Georgia Seed Development Group. And so that was really key. You can go to the next slide. And then obviously smallholder farmers. I think that's kind of the underlying, you know, message of a lot of our work is how do we increase the yields and the livelihoods of smallholder farmers. And as I said, this is really going to be focused a little bit more on how do those farmers access that research. We're all familiar with the NARS Extension Service farmers kind of pathway. Unfortunately, in Malawi, that's had limited successes. You know, looking at long-term yield trends, yields for most crops are actually declining in Malawi. So we saw that there needs to be a change on that. And again, it's tied into how we think about these farmers and how we go about it. You know, a very simple logistics challenge that many of you would be aware of is an extension staff ratio. In Malawi, there's about 3,500 farmers to every extension agent, government extension agent. So it's really hard to meaningfully address all the issues that need to be addressed with all those farmers. I think another important one, which goes back to some of those early slides talking about the market system, and also was brought up yesterday with an example of rice in Ghana, was what's a farmer's return on investment for new practices? If they increase yield, is there going to be a market for that now excess production? That's a very critical thing to think about here as well. Next slide. So this slide kind of looks at how AgDiv as a project categorizes their farmers. And it kind of turns out into a stratification that goes quite far. And so, as you've heard me talk about already, some of our core partners are diversifying tobacco companies. And those are farmers that, again, are closely tied into the market system and closely tied into extension. So this past season, the two main companies that we work with, they had about 7,500 farmers on a groundnut contract. And on that, under that contract, they are getting inputs on credit, which included high quality seed, inoculant, additional fertilizer, and in some cases, crop protectants. But we can see that's only about 7,500 farmers. The next two categories are, one is an extension farm, which I think some of you might be familiar with as well if you work with the peanut lab in Malawi. Horizon Farm has been a long-term partner to the Peanut and Mycotoxin Innovation Lab, and again, the Peanut Innovation Lab. And you know, they're offering extension services out to their farmers as well. JTI, Japanese Tobacco, is another diversifying tobacco companies that wants to just match their farmers with groundnut contracts. The next group is the Tradeline platform. So Tradeline is a microfinance institution that we're working with to offer inputs on contract. You know, that's largely an input package, and that's it. There's a little bit of extension, but not too much. And then you kind of have a next very large group that involves some NGO-linked farmers with organizations such as 1 Acre Fund. So as we think about this, these are all farmers that we're going to reach, but they might be reached in a different manner. You know, the contracted farmers and the tobacco companies will get kind of the full package. As here, that say they'd get the Rolls-Royce package, where the other ones might get bits and pieces of that. But I think it's, when you're talking about hundreds of thousands of farmers, we have found that it's helpful to start one place and then push that out. And we can go to the next slide because I think that's a good example. Yesterday, Allison talked a little bit about the Sabo videos. And so that's an activity that we were part of as well and involved a lot of these groups. And I think it's a good example of how something we do with one group can move out to the different ones. So a lot of the research and a lot of the putting together of these videos was done with these kind of first two levels, Pyxis and the tobacco company farmers, as well as Horizon farmers. They had been involved in some of the research in previous years that went into this video. They were involved in some of the review of the scripts and the video as it was putting together. And then they've also benefited from that. You know, there was some talk yesterday as well when we were talking about the Sabo videos is a smartphone the most appropriate way to share this information in countries where, you know, feature phones are maybe the more dominant type. That's especially the case in Malawi. Malawi has a much lower cell phone penetration compared to other countries, and especially when you look at smartphones. But you know, with those tobacco companies, they have an extension to farmer ratio of less than 100. So it's very easy to have an extension agent with a video capable device to reach a large amount of farmers. You know, then this was also shared with the Horizon farmers. You know, they're working with a bank to offer input credit. And as part of that, they have extension agents as well with smart enabled devices. So they're able to share with those farmers. And it kind of moved along this group of farmers until we got to the very end. You know, 1 Acre Fund was also a big user of these videos, and they are able to offer it out again to 25,000 plus farmers. So, you know, we don't always have to think about the smallholder farmer as the only user in the chain. They're the end user, but there are other ways to get that information to them. So I think that's an important one. And just going back to this kind of group, it's important to understand that each one of these levels or each one of these groups is going to have a different outcome, but they're still going to have some sort of improved outcome. You know, this core group under the tobacco companies will kind of have the best of everything. But the last group, just those NGOs, we're making sure that they're getting high quality seed, inoculants, and the base good agricultural practices going there. They might not have the best offtake example, but we're making steps to that way. So I think it's important to kind of phase in and think about how you can reach different groups of farmers. Next slide. And so that kind of really comes to how I kind of think about as a research and extension paradigm shift. I kind of always think that, you know, the NARS extension farmer network is kind of a little bit stuck in 1950s American agricultural research. And while that has obviously changed in the US, it hasn't quite filtered out to some of the countries like Malawi. So it's important to, again, bring in that private sector, see them as a very viable go-between between research and farmers, especially when we can find partners that are willing to invest or co-invest into that network. So again, this picture is David Jordan doing a training, again, on a tobacco research farm with some of their extension team. And so that's, you know, that's a very good kind of picture of what this next option could look for. And I think that's kind of one of the key things that we have done with the Peanut Innovation Lab and the other innovation labs. We've helped them move from being very focused on the NARS and academic research system to pushing it a little bit further out into some of these new markets. So we can go to the next slide. And so key to doing that is kind of just tweaking those research outputs. We can go to the next slide already, actually, on this one. So again, we're not changing the research. It's kind of the same research, but with a little bit of different packaging and thinking about the end users in a different way. And so again, we're going to look at a few more examples of where I think that's been quite successful in our project. We'll be talking about the same markets. And so the first one is, again, USAID and donors. And so this is a story, maybe it's not changed on mine, but we can go to the next slide. Cool, all right, thanks. This is a story that I've told Dave and Jamie and the Peanut team, but we also do work with the Soybean Innovation Lab, is one of the other labs that we work with. And there was a time, again, before when we could travel, that pretty quickly, one after another, first the Peanut Lab came out and did some visits. And as part of that visit, we had a meeting with the USAID mission here in Malawi. And then a few weeks later, the Soybean Lab came out and again had a visit with the USAID mission. And at the time, the mission team was very interested in what sort of inputs and what sort of input package should their programs be offering to farmers, and what, you know, bundle of inputs would give those farmers the highest yield and the best return on the investments. So with the Peanut Innovation Lab, we are doing agronomy trials. North Carolina State University and partners here, including Horizon Farm that you heard mentioned, as well as the national program and the universities. Soybean Innovation Lab also doing those sort of projects. Here they called them smart farm trials, soy management, appropriate research and technology trials. But they're both looking at what's the best input package for farmers for these crops. And that's what USAID was asking. Next question, or next slide, sorry. So when Soybean Lab was here, they were able to present a handout that listed some color-coded slides that didn't answer, it's again, it was based on, different scenarios, different contexts. So it didn't answer USAID's question outright, but it very easily facilitated discussion. And it helped, again, a USAID representative that was not an agronomist understand the research a little bit better. And it stuck with them a little bit easier. So, this is, I think, a really good example of just kind of changing your programming or changing how you discuss programming to meet your market can go a long way, because then we stopped having the basic question anymore. It wasn't, what is the best input package? It was, oh, what sort of input packages are you using? Which different groups of farmers are getting offered which package? Which again creates some very interesting research activities as well, or research questions moving forward. So we can go to the next slide. So again, the private sector. This is a bit going back to what we were talking about. We were at a kind of a starting point with some new partners, and they needed to know where to start. What are the basics of groundnuts? They had that same USAID question, what sort of package can we offer? They had 25 years experience of offering different tobacco packages. They wanted to know the same sort of things. If we offer this to farmers, will they see a return on investment? And this kind of came out that there wasn't a standalone groundnut production guide for Malawi. And so as we were having these conversations with the Innovation Lab team and our private sector partners, it was kind of this, what is known and understood, based on the experience of the Innovation Lab team and their local research partners, versus what do we still need to answer? And it was kind of finding that happy medium where a researcher could say, I would recommend this, versus I don't know the answer to that. And this kind of gets back to, I think, a little bit about this PLC conversation that's coming up as well, is this demand-driven research and being at the beginning of your research and knowing who's going to be the end user of that research. So we can go to the next slide. And so we now, thanks to the Innovation Lab and all their research partners, we now do have an excellent production guide here. And I think what's important about it is it's, my more limited understanding of some of these different production guides is it goes beyond just kind of an input recommendation. It looks at the return on investment. It looks at the different risks that farmers are taking. And it's very well adopted to Malawi and a lot of our partners here. We can go to the next slide. And I think on the next slide, I made sure I got everybody's name on there who was involved. And hopefully I didn't miss any, because they obviously put a lot of work into it. But I think what's really important about this is it's set up and hopefully will be accomplished that this will be a living document. It will be closer to extension and production guides in the United States, where it's updated on an annual basis to reflect trends, to reflect new research coming out. And I think that's also a really important, just tweak of a research output. I think a lot of times, especially from the donor side, they think that research is finished and then that's done. That's the end of it. And a lot of times, production guides kind of sit on a shelf in a lot of these contexts. So I have a lot of hope for this production guide moving forward, because there's been a lot of work put into it. And I think it's ready to go out there and move beyond just being a guide. Next one, please. Next slide. And again, as I mentioned, key to all of this has been the work that we've been doing with researchers, and especially the in-country researchers here in Malawi. And again, this is the result of previous USAID investments into innovation labs, into students. And it's again kind of making sure that that continues to be a usable and a viable network in country. So I'm going to quick highlight two of the projects that we're working on with Innovation Lab and local researchers here. So we can go to the next slide. So with Dr. Limbakani Matumba from Luanar here in Malawi, we're doing, I think, quite an exciting aflatoxin management study that really brings in a lot of strong partners and answers some very critical questions. So, you know, Malawi is making a move towards groundnuts being a cash crop and an export-orientated crop in addition to being a staple crop. And obviously that then brings aflatoxin to the fore. So this actually kind of started out as a AflaSafe trial. You know, many are probably aware of AflaSafe. It helps reduce, or has potential to reduce aflatoxin levels when applied in the field. So that has become in the last couple of years a release technology here in Malawi. So USAID was interested in, well, where is it possible for us to use that? We kind of said, well, I think there are a few questions on that. Let's look at what aflatoxin levels are coming out of farmers' fields. And then it kind of moved into working with one of our partners, Pyxis Agriculture, one of the diversifying tobacco companies, is, well, how can they integrate that into their production and post-harvest activities? So we actually brought in the Innovation Lab and Frank Nolan, who was also mentioned yesterday, using the same machinery that's going to the breeding programs, and set up really a buying point process that looked at aflatoxin levels, grading, quality, and really replicated in the US the federal state inspection process. We can go to the next slide. And so that's been a really exciting research project. And again, it doesn't change the research. It doesn't change how we're doing the research. It's multi-year. It has high replication. Working with a private sector partner, I believe this year we are successful in getting about, I think about 75 control plots and 75 treatment plots on the AflaSafe, and then many hundred test points from the buying process. And we've also involved student involvement, and I believe the student that worked on it in the first year is now an employee of the company that we're partnering with, and is doing this as their professional career now, the same sort of thing. So it's a really good example of how research can go from the innovation labs and the institutions directly out to the fields, where really adoption is already a part of the research. Might not be for all the questions, but it's a core part already. Next slide. And then the other one that we worked on was a peanut soy drink. And this again kind of goes back to our work with both the peanut lab and the soybean lab, and which would be a tastier drink, a peanut drink or a soy milk, essentially. So we're working with Dr. Agri Gama, who came out of the previous peanut mycotoxin lab, to integrate his PhD research that was done around a peanut-based drink with an activity that we're doing around soy milk. So AgDiv works with about 2,000, mostly women in rural areas, around household soy milk production. And this kind of came to us as a kit with a recipe, but we had the taste preference, as well as even some of the nutritional work hadn't yet been done. So we can go to the next slide. So we worked with Dr. Gamma to do some of that kind of nutrition market and consumer preference research. And then, let's see, where's my slide? And then we combined it, so we did that on the soy milk, but then he also developed a peanut soy drink, and we did the same research to see if ground nuts could be the flavor element into the soy milk, because I think Sil would say that just unflavored soy milk isn't the tastiest. So a lot of our processors do add sugar or they do add other flavoring. But what we have found with this research is that adding in roasted ground nuts and roasted soybeans increases flavor and increases preference, as well as adding a protein element. So that's also an exciting research project here. So we can go to the next slide. And so really, I think kind of going back to the basics, you know, this collaboration with the Peanut Innovation Lab has really been the foundation and made everything we've discussed possible. As a regular implementing project, if we were just on our own, we wouldn't have been able to accomplish this because the research would have remained a mystery for us, and it would have remained a mystery for our partners. You know, it maybe would have gotten out there eventually, but it would have been a bit slower. It would have been a bit more work. I'm not saying this wasn't work, but you know, there would have been additional steps that would have been needed to change, and we would have lost some of the efficiency. So I don't think it, you know, I think they would probably say it wouldn't have been possible without AgDiv. I'll say it wouldn't have been possible without the Peanut Innovation Lab, but I guess that's the foundation of a good partnership and success there, is we've both brought our own capabilities to it, and we've ended up with a sum that's greater than the parts. So I will leave it there. I can quickly do a few questions that I've seen come up. So in total, this season, for Fareed's question, we reached about 25,000 farmers under an input package program in one way or another. So a portion of those would have gotten a full package with the extension and with an offtake agreement, and others would have gotten, you know, maybe just an input package for just seed. Others might have gotten an input package with seed and an offtake option. But this year was about 25,000 farmers, and that actually represents probably 99% of the farmers receiving a groundnut or a soybean input package on credit in Malawi. Compared to somewhere like Ghana, there is not a lot of input packages on credit offered to farmers.
Jeremy, I think in the interest of time, just because I know we've got to get a little bit of a break in here and come back, we'll cut the Q&A, unfortunately, a bit short for in person here, but we can do more in the chat over the break, and I'll take my MC's prerogative and just tell one useful story coming from the ME. There was kind of this nice origin myth story about the first conversation that Jeremy and I wasn't there actually, but had with the management entity and his boss, Carl. They sat down and said, "We've got all this money and we don't know anything about peanuts, so what should we do?" And I think what was really useful about that first reaction as a taxpayer was like, oh my gosh, what have we done? But then I think the reality was it sunk in that they were really open to collaborating, listening to us, and they really created a lot of flexibility for us as the lab coming in, which isn't always easy with project life cycle and when the budgets are made and all that kind of thing. So that was really useful. And it showed a difference too. I think a lot of projects rely on consultants to do this work, whereas the Innovation Lab, we've kind of acted a little bit like a giant network of consultants, but we have so much depth of knowledge in it that it's not just surface. And that's from someone who worked as a consultant at some point in my life. But so with That, and I did want to say one thing too, from a researcher's perspective, it offered us a huge, like, immediate scaling, and some of our plots, like, it's just so much more robust in the data that was collected, because we can get, you know, the breadth of it is way beyond research stations. And I think it gave us a lot of networking beyond our NARS partners, and also helping our NARS partners link with private sector and build those relationships that don't often happen very easily. And a lot of that was through AgDiv. So again, a good, you know, partnership is built on all those spokes. So Jeremy, you covered a lot of ground. So I'll stop there on our conversation related to that. I'm seeing it's 11:50 now. I think we need probably, oh, 11:51 just turned, but I think we need 10 minutes break. So why don't we come back right at noon? And again, please continue the conversation, questions with Jeremy in the chat, and we'll come right back at noon. And in the middle, we'll have this continuation of the videos that Allison produced. So thanks a lot, and we'll see everybody in 10 minutes, 9 minutes. All right, welcome back, everybody. I hope everyone had a chance for a bit of a stretch. Again, in the name of time, because we've got such a full program planned, I'll jump right in. Looks like we're still got good chat going on with Jeremy. Oh, thanks again, Kristen. I always forget these polls. So if everyone could do the poll quickly, I'll introduce our next speakers. All right, the results are in. Pretty even split across the topics there. Results. Good. So very much related to our next question is, of course, you know, innovation labs are often, you know, we are research for development. So we're doing a lot of research along from basic all the way to very applied. But then I think sometimes we don't follow through as well as we could on thinking through the impact pathways to how do we get to how do we get these things out there? I think Jeremy gave us some nice examples, but I'm going to invite our next two speakers actually related to USAID's shift towards this product lifecycle way of thinking about our research outputs. For those who were on yesterday, Daniel Bailey is our AOR, our Agreement Officer's Representative. That's one of those USAID acronyms that took me a very long time to remember. But Daniel has been working with us since our peanut and mycotoxin innovation days, so he's familiar to many of you. And the other speaker that will be talking potentially some is Jim Gaffney, who I have not met yet, but I just learned has some additional connections with folks connected with our innovation lab about this. So with that, I'll turn it over to Daniel and he can give us our update. Thanks.
Thank you, Jamie. The product lifecycle, something I teased yesterday. Some of you may have actually already seen a presentation on the product lifecycle from using the USAID approach. And also the target product profile concept, which I know many of you who are breeders have probably worked with the Gates Foundation and Crops to End Hunger to develop much more thorough target product profiles. I'm just waiting for the presentation to come up here. But we will I'll go a little bit over the review of the product lifecycle framework as we are developing it. And then we'll talk a little bit about how it overlaps with how you currently report into FTFMS, or now DIS, on your research phase. And then we can stop and ask, take questions if you would like, if you have any. And so if you could please go to the next slide. We will, okay, next slide. So the product lifecycle framework is a project management tool to manage from early discovery stages all the way through registration of a variety, new variety, through scaling up, and then finally decline and phase out, where a new improved variety should be introduced and scaled up. Many of the varieties, as I know you're probably all familiar with, that we work with in Africa, are usually quite old, and their genetic potential for yield and fighting disease and other pressures is usually quite weak. We have developed this product lifecycle framework through consultations with Syngenta Foundation and Crops to End Hunger and Gates Foundation and additional other partners, strategic partners of USAID. And it starts with the target product profile. In the coming years, and in the coming year, you will hear a lot more about the importance of a highly detailed, market-oriented, based on market research and segmentation analysis of a target product profile. For USAID purposes, this will also include, or could include, social indices, how a particular variety needs to meet the needs of the particular niche of USAID target farmers. So you should expect to see characteristics of a variety for how it would impact women or youth or other market audiences. The second stage is the discovery stage, and that can be very early research and discovery, such as the discovering the genetic locations for a particular trait, or it could be in the machine manufacturing space in developing new mechanical tools, or even in the social science space of identifying, identifying causal linkages between various aspects of how it would impact men or women differently, or different ethnic groups differently, or between different countries. We've got the stage 3 is proof of concept, followed by validation, and then selection. So I'm just going to run through these a little bit more quickly. So, and then finally, regulatory approval. We hope that the goal of all breeding activities in our innovation labs is to at least get to stage 6, regulatory approval. In reality, we would hope that you could, although we understand breeding cycles can take years to get to that point, but ideally we would like to have at least 1 year between regulatory approval and the end of the innovation lab, so that we can work on stage 7, commercial introduction. And that's where your partnerships with private sector will come into play, or if private sector is weak in the country, then working with nonprofits, government, other USAID partners. In reality, you should be working with all of these entities simultaneously, regardless whether there's a private sector pathway or not. And then typically the stage 8, growth and maturity, that will be more aligned with what you might call standard USAID programs. Mission uptake in their programs, and scaling out from there. Can you move to the next slide, please? So here I've overlaid what was FTFMS, now it's DIS, research phases onto the product lifecycle. And you can see that phase 1 overlaps with stages 2 and 3, phase 2 with validation and selection, phase 3 ready for release, and then finally phase 4 demonstrated uptake. And then our standard FTFMS indicators take over in stages 8 and 9 through the phase out. So what we would be asking in the future is that you would identify which stage you were in, and then that would also feed into the research phase report. Next slide, please. So why are we moving to this new framework tool? It's probably no secret that USAID and innovation labs, and previous to the innovation labs, the CRISPs, and also our work with the CG centers, we have not always been terribly successful in moving new varieties or research outputs from the lab out to the field. And we see that by the fact that the average age of varieties in fields across all crops, particularly in Africa, are 10, 20, even 30 years old. And in order for Africa to really experience a revolution in agriculture and economic growth driven by agriculture, that average age of varieties must come down. We need to have newer varieties more widely adopted at scale across Africa. And we have not seen that the varieties that we have been developing, supporting through our research efforts, are making it into deep adoption in the field. The goal of the product lifecycle framework is to provide a new management tool that will help guide you as researchers through the stages and through the network creation process to make sure that those later stages are fully teed up, fully prepared, even back when you're still in stage 2 discovery, stage 3 proof of concept. There will be, what you're seeing here is just so if you were to put this in an Excel spreadsheet, you're seeing the very, top level rows. The rows below would be full of leading questions for you to work through, and in terms of making partnerships, seeking alliances, collaborating with later stage partners, making sure that your regulatory approval is being set up early on, etc. Next slide, please. And I'm not going to go through these in depth, but I believe that the presentations will be available for you later. And you can read through some of these, some of the proposed actions to take in each stage, in stages 1 through 3 on this slide. And that, if you can go to the next slide, please. In stages 4 through 6, which is through release. Next slide, please. So what is in it for you? Well, the PLC management tool will help you manage your existing work more efficiently with adequate preparation for the future stages. So that's making sure that all of those questions that USAID managers will ask and mission folk will ask are answered early on. It will create greater transparency with the missions and their implementing partners, particularly with missions, because we are also proposing to missions that they start managing at least components of their development work according to the product lifecycle. By putting the research and the scaling projects on the same product lifecycle, the areas where the work overlaps will be more readily apparent. It will provide opportunity for you to see where you can contribute to mission scaling efforts, and it will provide missions the opportunity to see where they can provide feedback into your research. And it provides a common framework for collaboration. So Fareed, I'll get to your question here in just a moment. Okay, next slide, please. So just in summary, it's a management tool. It's a common framework as we drive to scale. It will help us overcome the unknowns and the nebulous nature of development work. And it provides missions and innovation labs a seat at the same table, so to speak. All right, next. So questions and discussion. So Fareed asks, is it the responsibility of research or should this be moved to other organizations? That's a great question, Fareed. It is primarily the domain of research. And I only say that because from our side in US, where innovation labs are managed in Washington, DC, we only have direct input and control of the innovation labs, the research. While we hope that missions will adopt the PLC also, we can't force them to or guarantee that they will. But the more that the innovation labs use the product lifecycle framework and the more usefulness that it shows to the field, to missions, then they will be more likely to adopt it also. Having worked in a mission in Guatemala, it's readily apparent to me as a foreign service officer why this is such a fantastic tool for missions to implement as well. And that's because we tend to move around countries, every 2 to 4 years. And when we do that, the programs, the processes, the management tools in place in each mission with each program are different. If we start moving toward a common management framework, then it's much easier for us to quickly get a handle on what is being done in country. When we move to a new country, it provides that opening communication. And I don't see any additional questions coming in yet. So at this point, I'm going to ask my colleague, Jim Gaffney, if he wants to add anything to what I've said.
Sure. About the, is this the responsibility of the researchers? Yes, it is. But that research team has to reach out to others in the value chain, all up and down the value chain, to get that market segment analysis right and to especially get that target product profile correct. Because if you don't get that product profile correct at the early stage, your product lifecycle is almost doomed to failure. It's not saying if you get the product profile perfect, it doesn't guarantee success, but boy, it really helps. And when you're talking about product profiles, you have to talk to so many other people. And this is where social scientists become extremely important to what we're trying to accomplish here. The social scientists have a lot to say about what goes into a product, because who uses the product? Is it the women or is it the men? What's it used for? What, the cooking properties? There's so many things that go into a product profile. Then you have to prioritize what goes into the product profile so you're not confusing the heck out of the breeding team. So it's quite a process. But yes, the research team has a big responsibility here to be inclusive as they develop the product profile, and then as they go through the product lifecycle. At each one of those gates, before you get to the next stage, you can review where you've been and what you need to do. And if you don't meet the criteria of that gate that you've set for yourself, hopefully you've set some pretty tough criteria, you don't go to the next stage. You don't continue the project until you've met your criteria along the way. And that, again, is where the social scientists become really important, helping move products through the process. Thank you.
Before we move to the breeders who are going to talk on the target product profiles and give us some examples and lessons that they've learned from that, there is a good question from Stephen Arthur, who's working on a cropping systems and agronomy question. But thinking about how these apply and to things, because it is very much sort of variety driven, the language and thinking around it now. But maybe you guys could quickly address that before we go back and talk about varieties and pipeline.
And that's a great question. The target or the product lifecycle management framework, as we envision it, is not intended only for breeders. Every research activity should have a target profile of who they are trying to reach and what their needs are. So in that respect, a target product profile also is not confined only to varietal research. And same with the product lifecycle. Every new tool that we can provide to farmers has a life cycle. You're doing the initial research, you're validating that it is working correctly, you're solving issues that come up, and finally you're ready to scale it out. But again, if you're working on a new agronomy practice or an improved agronomy practice, if you don't have those linkages with the extension folk who are extension staff who are, maybe they are in USAID implementing partner programs, maybe they're at the National Research Organization, maybe they're at the in the university system. If you don't already have, really have made really strong connections with them, then what happens at the end of the innovation lab is that improved agronomy practice goes into a journal and then it's forgotten. So we are trying to stop that cycle of providing funding for research, getting some great results, gets written up in a journal, a new variety is released, but then it just stops because there isn't an organization ready to scale it out.
Let me just add something to that, Daniel. Yesterday, at yesterday's meeting, I heard a comment, I think it was from Sari Blakely, about social scientists, and social scientists don't have a nice, neat product that fits into the product lifecycle, which is actually very true. However, a product lifecycle still could be used for social science efforts and projects. If it's a knowledge product, if you're trying to reach women or youth, empower youth, there still is probably a knowledge product that has to be really thoroughly researched as a target product profile type of research early on. And then you set your criteria for how that moves through the product lifecycle so it has maximum impact when you do get to the end and you have developed your whatever it is you're trying to deliver. On the other hand, the other way social scientists need to be involved is with a true, nice, easy product, like a seed variety, or maybe it's yesterday the thresher, the small threshers. That would be a perfect product for the product lifecycle to move that through. But ideally, your social scientists have been involved in helping identify how to, build that piece of equipment so it really hits its target when it's developed and it goes commercial. So thank you.
Yeah, really excellent points, and I know these are kind of where the friction and learning is going to be in the adoption of the framework. I am going to move to the breeders because we have I think 4 of our breeders that are associated with the lab who have experience with these target product profile approach and are going to share some of their experiences. But I'll ask Daniel and Jim, and we can come back to this hopefully if we have some time, and certainly in the breakout sessions, this is going to apply to everybody. So we'll all be learning together on applications for this, but I think maybe as our breeders are are presenting, we can think about some of their lessons and how they might be applied to other disciplines and other outputs. So with that, I think our first one will be David Okello, the national the orange breeder from Uganda, who's involved in many of our projects and has been a great example of being our technical working with social science and it's just is a good point of reference for all things peanut in East Africa. So David, if you're there, I'll turn it over to you.
Yes, thanks everyone. Welcome to my talk. It will be rather quick because time is not our best ally now. I'm giving this talk on behalf of the Ugandan National Groundnuts Improvement Program. Next. Yeah, the team composed of the biophysical and the social scientists, and 4 out of that team has actually been gender mainstreamed, and actually I'm a certified gender trainer. Next. Yeah, so basically in every breeding program, these are the the salient steps, setting out the priority, then creating variability, earlier testing, late testing, then of course the variety release and diffusion process. This is normally the breeding steps we usually take. Next. Yeah, that aside, the Excellent in Breeding platform and some folks, they came out with this state gate process, which talks about, from product program design, that is stage 0, up to stage 6, whereby they seed multiplication and the client release. And in all this, then there is need for knowing your customer, knowing the market, and gender should be enshrined in all of these processes. Next steps. Yeah, again, then product profile, basically it is a set of targeted attributes which a new variety is expected to have to be successful out there, meeting the customer or defined market segment. And it should be able to have all the necessary attributes for adaptation, should be able to have all the traits needed to be successful out there to compete with the flagship varieties, should include at least 1 or 2 traits which is significantly improved. And then for the nutritionally related attributes, it should be having the threshold of the nutritional level. And then in doing all that, one should keep in mind that whatever you're doing could have a negative consequence on the other. So the do no harm approach comes in. Next. Yeah, again, on slides, one needs to know the target agroecologies, one needs to know the value chain. And then with that, then you need to know your customer, you need to know the market you're looking at. From that, you should be able to develop, the ideal product for that market segment. And then you then generate the product profile. This is a slide which for further reading, you can check it out on Ashley. There's a book on gender G+ concept, which actually explains this concept in there. Next. Next, please. Yeah, then the Excellent in Breeding platform, demand-led breeding, and then they came out with some kind of technologies which define the kind of traits we're looking at. Like, for instance, must-have trait is an essential trait which a variety should have. Important trait is a trait which probably variety should be having, which should interest the customers. And then nice to have. These are some of the traits which provide additional advantage over the new variety. So these are the terminologies which has been adopted and should be used frequently with all the breeding team out there. Next, I thought I could put that one up. Next. Then when one is making selection, then one needs to look at the traits which has been enshrined into the into that product profile. Which trait should be maximized? That is the trait which needs to take advantage of the genetic gain and should be readily improved. Then the threshold traits, these are the nutritional one whereby there should be a minimum acceptable level. Then opportunistic, which are basically the exploratory one, or the one which exploits the normal variation, like higher leg. So when one is making selection and you have some of these objectives, you should know the levels one should go into. Next. Then, for example, these are the kind of traits the stakeholders want in groundnut in Uganda. For example, the grain yield. The stakeholders there are disaggregated in men and women, and the benchmark there should be, the yield should be 15% above the flagship, and it is the must-have trait, and then one should maximize that. Then it could come to traits like oil content. If you're looking for butter, you should know, like, okay, this is the minimum oil content needed in a variety. That makes it a threshold selection objective. And then traits like the fodder, home yield. This applies both to men and women. Should be greater than the local variety. It is an important market priority, but is opportunistic. So if you have the traits generated by when you profile what the farmers need, you need to know your stakeholders. What are the agreed benchmark? Then what are the market priority? Then when you're making that selection, you know the levels you tag them in, and then because you rank them, should it be short-term, medium-term, and long-term objective. Next, for instance. Yeah, so the target use of the end products. This can be food, for example, for us here, can be confectionery. It can be for processing, industrial use, RATF, oil, feed and fodder. And then we are delivering this through 3 different botanicals of groundnut. Valencia actually occupies only 2% in Uganda, but Spanish and Virginia takes care of 98%. And we motivated in implementing this target product profile development because of the available market, the available ecology. We know the ecologies we're working in. And then we have diverse germplasm with spectra of nutritional attributes, oil content, maturity profile, sugar, biomass, and then having a diverse team of social, biophysical, and with the stakeholders on, we believe that, these are the kind of motivation one needs to have in a breeding program. Next. Yeah, then I was told by our colleagues in the social side that breeders tend to tag a product profile to target agroecologies or to the variety, but I was retooled that this should be targeting how that product is used. For example, food, confectionery, processing, and then in that case, then what is the pipeline you're using to deliver on what you promise in? I mentioned earlier on that we have 3 botanicals we're dealing with. For instance, for food and confectionery, we have Spanish, that is there's red and tan, because the south, west, and central Uganda prefer the red skin one, whereas the tan is preferred in east and north. And then the must-have trait, for example, is granular rosette disease resistance, which should be less than 3 on a scale of 1 to 9. Leaf spot, the same thing. And then the oil content, we eat lots of peanut butter, so it should be at least 43%. And then it should have none to 14 days dormancy, because we have bimodal rainfall, and we tend to grow groundnut twice in a year. And then the maturity profile for the Spanish should be less than 90 days. Most of them, they escape, the mid and end seasons drought. The value-added trade in there includes things like confectionery, especially for the boiled, soft shell, ease of shelling, blanchability, should be sweet, aroma should be, greater than the check. Extra early, if you could have, now we have some varieties, some lines actually, which matures in less than 85 days. And then the game-changing or the winning trades should be things like, high iron, high zinc, amenability to mechanization, promiscuous anthesis, promiscuous pegging, industrial use. Then if we could come up with the groundnut varieties which are free from toxin and allergen, this would actually be a game-changing thing. So like continuing with the Spanish, the current varieties we have in Uganda, for example, the Serenat 5R and Serenat 60, these are our flagship, but they replace Serenat 3R and 40 respectively. So for the Valencia, for instance, the skin type varies across the region, but the must-have trait should be groundnut rosette resistance. This is the trait which lacks actually in most of the Valencia, yet the Valencias are important for the boil market, for example. So the soft shell, blanchability, aroma, extra earliness should be, the value added trait in there. And then the current varieties, which are 1969 releases, are Red Beauty and Chole White. And then we believe that when we come out with the Valencia, should be able to command, and Knox of these two should be able to command near 100% market share. But for the Virginia, the must-have traits should be drought tolerance, because they tend to be medium to late maturing. Still, dormancy should be 0 to 14. Seed size should be medium to large jumbo size. And then of course, GRD and dead leaf spot resistance should be in the background. Value added trait is the same as the rest. Game changing one, the same as the rest. But the current flagship, the 14R for the red skin market type. And then the tan one is the 11T, but those are the ones they replaced. So this is the kind of the targeted product profile we develop with EIB and with ICRISAT. And this is the one we're using currently. Next slide, please. Yeah, what I learned from that is that the target product profile is a living document and should be managed regularly. And it is owned by the entire value chain. These are the folks we got in at the stage 0. And the product profile is based on the best knowledge at the inception, whereby you brought all these stakeholders in a platform, and they came out with that. It should be flexible in line of the available evidence, the data at that time, and then should be committed. The whole team should be committed to the set goals and the expectation of our end users. It is time bound. We encourage gender responsiveness in all of it. And then the current flagship automatically become a target for replacement. So if we look at it that way, then the product life cycle actually fits in this one so well. Next slide. I think that one is the concluding slide. I thank you, and I thank the GREAT. This is for Gender Responsive Equipped for Agricultural Transformation, which enshrines gender in our breeding program, and then the Excellence in Breeding platform, which has been part of this, and of course, NARO, the organization we work with for pension. I thank you all.
Thanks, David. We'll move right into our next speaker, and if folks have questions, certainly in the chat box, and we'll come back, and if we have a bit of time at the end, we can, but a lot of these we can translate into the breakout sessions too. So Issa Faye from Senegal, if we can get his slides up, and we'll just try to be brief, and I appreciate it.
Good afternoon, good morning, everybody. I would like to take this opportunity also to thank the Peanut Innovation Lab Management Entity for giving us this opportunity to give this presentation on behalf of the Senegal team. Daniel Fonseca, IC2, as breeders also working with us in Senegal. So go to the next slide. Hello? Next slide. Okay, thank you. Here I'm presenting a little bit the outlines of this presentation. I will be coming back a little bit about the context, the definitions and the conceptualizations. Then we will go through a tentative target product profile for Senegal. And then we will be talking a little bit about the bottlenecks of product life cycle in Senegal. Go next. Yeah, if you review the literature, you will see that a target product profile is a key strategic document that lists the principal desired features of a product category. It needs to be developed using a large consultations approach with all stakeholders, especially product end users. And it has two ways in which there is two ways in which a TPP can be used. As a first step in developing an entirely new product category, but also as a first step in initiating improvement or change to an existing product category. And both are very important if we want to make impact and to develop the peanut industry. Go ahead. Yeah, if you take the case of Senegal, I would like to talk a little bit about the agroecological zones we have in Senegal. In Senegal, as you may know, peanut is almost grown everywhere, from the north to the south. But the agroecological zones are different. In the north, the peanut are produced on the irrigated conditions. But from the central to the southern part of the country, the production is under rain-fed conditions, and drought is the main constraint that we have. But we have also other constraints like some diseases like early leaf spot, rosette, and also some others various like rosette diseases. And if you see this map, it shows you clearly that we have in a given agroecological zone, for example, if you take the central regions, for example, in Jurbel or in Fatick, you will see that we have different varieties that are intended to be grown in this area. We recommended these varieties. We have some ruling varieties, and we have recently developed some new varieties that should be replacing the old one. But as I will come back later, replacement of varieties is very difficult, and it's a challenge. And I think with the initiative that we have now, maybe we'll be working with the social scientists to develop the strategies that will help us to make this change, to replace the old varieties by the new one. And we know that we have very good new varieties coming in, but there is a lot of challenge that we are facing now for the replacement of the old ones. Go ahead, please. Okay, next slide. Next slide. Okay, here we have all the different product concepts. We have also estimated the area. For example, if you take the northern part of Senegal, where we have less than 300 millimeters, between 300 and 600 millimeters, which is a little bit dry, we need to have short duration varieties that can mature after 90 days. These varieties, if we estimate the area, their acreage is around 0.2 million of hectare. And in this area also we have aflatoxin contamination, which is really as an important constraint that we have to do with when we are developing the variety in this area. We have one check which is 55-33, which is quite good, but it has not resistance to drought. It is drought tolerant, but the yield is a little bit low, less than 1 ton per hectare. We know also it's important now to have higher lake varieties, because it's getting important for the international market, and that's why in the replacement of the variety, we should think how we're going to have a variety that will have the same characteristic in terms of earliness, drought tolerance, but also having higher lake content. If you go down a little bit between Jurbel, Kaolack, and Fatick, you may have rainfall up to 800 millimeters. So in these regions, it's a very important, it's a large region which is account about 50% of the total area of peanut in Senegal. And in this area, the the rainy season duration is around 3 months. And here also, we think that it is important to develop varieties that can cope with drought tolerance, because in this area, we may have drought spell during the early stage, but also at the final stage. So having drought tolerance in a variety will be very, very important for guaranteeing a high yield. But also, farmers want to have high oil content varieties, and in this area also, early leaf spot is very, very devastating sometimes, particularly if we go to the zone of Nyoro, Kaulak, and in this area, it's a little bit wet, and this is like early leaf spots can be very devastating. And dormancy is also very important, because the end of the rainy season is very unpredictable. We get some rains coming after the maturity of the peanut, and this can cause some pre-harvest aflatoxin contamination. And so we need to have dormancy, frantic dormancy in these varieties. We think also that having high oleic as a new trait will be very important, because, you know, the government, the Senegal government, is thinking to develop the peanut industry, and one of the subsectors, the market we are targeting is the Asian market, like the Chinese importers coming to Senegal buying peanut, and yeah, we think that in the near future we have to have high oleic varieties, and this trait is now in our process. It's one of the criteria we are using for selecting for the new varieties that will be developed in the next feature. Go ahead. Next slide. Okay, we know also that peanut oil is now facing a very big competition with others, oil from soybean and others crops. And now we think that the confectionery type is really, really important, and we need to boost, and we need to develop edible groundnut varieties. But we know how it is important also to keep in mind that this market is very stringent. You need to have very good quality peanut if we want to be very successful in this market. And that's why we have recently developed some lines that are really, really good in terms of seed size, and they have also high oleic content, because we crossed one variety from Texas A&M University, Schubert, that we crossed with a Jimbo, a Virginia type from which has the biggest seed size, and we have segregating lines that are very, very nice, and we think that we will be having lines that can fit to the local conditions, and to be able to develop the confectionery market for Senegal. Yeah, go ahead. Next slide, please. Next slide. Okay, here we are. We want to come back a little bit about the bottlenecks of the product life cycle. It's important to develop varieties, but once the variety is now out of, it has more than 30 years, generally you don't have genetic purity, and it's very difficult to maintain this variety. It should be replaced, but low rate of commercial seed use by farmers, because we have a formal system for producing seed, but I think it is relatively poorly performing, and we need to improve the seed system if we want to be able to have a product life cycle working well for peanut in Senegal. And we have noticed also that from the social science studies that low variety uptake is also a very big issue. We still have ruling varieties which are really old, and we need to replace these varieties to make sure that we have a good peanut industry in Senegal. We have seen also that there is a little interest of the private sector in dealing with the peanut seed production, and I think we cannot develop the peanut industry in Senegal if we don't have a good peanut seed productions, assuring a good supply of seed to all smallholder farmers. And maybe this is due because of the self-pollination reducing the rate of genetic deterioration. Farmers keep their use their own seed, and it is also maybe because of the high sowing rate. You know, for peanut you need 150 kilograms per hectare, and so you need to have very big waste houses to store your seed, and maybe it's not easy for the private sector, but we need to think how we're gonna improve the implications of the private sector in Senegal in the peanut value chain. Low seed viability, not allowing also option to store seed beyond a year. You know, in the, peanut is special in that aspect. You know, you cannot store peanut more than 1 year if you don't have very good storage facility. And maybe this is one of the reasons why the replacement of the varieties and the implications of the private sectors is a little bit slow and very limited. Go ahead. Next slide. Okay. Next slide. Okay. So we think also as recommendations, which are very important, we think that we need to think and to establish a sustainable breeder seed production scheme that will ensure a good supplying seed system of the newly released varieties. Because to have enough commercial seed, you have to make sure that the breeder seed are produced at the right time and at the enough quantity. So we think that this is very important to improve the capacity of ISRA to ensure sustainable breeding seed productions. And beyond the formal seed system, also we think that is important to develop some strategies to also improve the informal seed sector, because we know that farmers now are organized in cooperatives. They are organized in groups, and using this way, we can increase the use and the adoptions of the certified seed, but also the adoption of the new varieties by the smallholder farmers. And we think also it's important to develop contractual arrangement between seed producers and farmers organizations. And we know that today in Senegal, we have a network of organizations which is really having more than 50,000 members. So we may use this farmers organization to increase the efficiency of the seed system, but also to develop some strategy for the large adoptions of the new varieties and technologies that are being developed by the research, the National Agriculture Research System. Okay, thank you. Go ahead. Oh, thank you very much. This is the end of my presentation. Thank you.
Thanks, Avery. Thanks, Issa, for that. You covered very good examples and some lessons taken out of there. I think given that we're really running out of time, we'll have a chat with Richard and Justus to catch up on their presentations. And I think we're going to end up having to conclude, but what I'd like to do is take some time now to have a bit of Q&A with folks while we have the majority of people on, and we'll end up having to, just because we're out of time essentially for the breakout sessions, we'll sort that out, and we do have one planned for tomorrow. but I know, and I'm getting some chats from people about availability and things and challenges, but what I'd really like to do now is think about while everybody's on and Danielle and Jim, or Daniel, sorry, and Jim, about the application of the PLC, things that we've seen from David, Okello and Issa and their varieties, and just to have a bit of time while we're here to talk about how that might apply to some social science context or agronomic things. And so I want to open it up if there's some additional questions, I think, or maybe even folks that are working on some of those, that other things beyond varieties that are just helping us think through this, some examples perhaps. I was trying to think through what it means to think about a market segment for something like an RCT. For example, we had our regional meeting with USAID talking about agronomic practices on conservation ag. And in some ways, people have been doing these for a while, and there is a product out there. Maybe we can start to work on how to brand it, and like, for example, the doubled up legumes has become a kind of a brand name for a practice that exists and has been worked on and research supporting it that can be scaled. And it helps us think through how those might be adopted and down chain things. So does anyone have any other questions for our presenters, going back to Daniel and Jim?
I was just going to mention quickly, I had a lot of experience with this kind of thing, particularly about 15 years ago, working on projects from the Gates Foundation, and we had in 4 crops, and I was kind of the point person on human health for that. So just to say, I'm a resource in the group as you think about these things.
Thanks, Mark. That's really good to know as well. You have anyone else? I was even thinking about our team from Ohio State and ENSA with the shrub project. You guys have done, taken what is kind of a traditional practice in some ways, and you've improved upon it, adapted it, and had kind of branded it as the optimized shrub system.
Yeah, that's a good point. And when thinking about this like a product, it does kind of jar your brain a little, but if we can think about it as a way of getting to scaling instead of to market, it does really work. And it does require that kind of branding.
This is Jim Gaffney. I'll just make a comment here about other activities that's going on. The CG system and the Bill and Melinda Gates Foundation, as well as with USAID, we're working on this really hard with the CG system as well. And there's a lot of activity within the CG system to get the market segment analysis, target product profiles, and align with the same product lifecycle framework that Daniel presented earlier. And they're working with the NARS as well in different ways. So in some ways, I think it's important that we are aligned around this, so we at least understand the terminology, understand what we're trying to accomplish. If the innovation labs and the CG system are telling the NARS 2 different things on any given day, that's going to be really confusing for everybody. So getting the language right, getting the understanding around these things is important, I think. Thank you.
Any other thoughts and comments around this? And again, Richard and Justus will be in touch and try to figure out how we can shuffle. We just have had a lot of shuffles in our agenda to get things done, and we've made a commitment to stay between kind of 10 and 1 o'clock because it's getting really late. So Kristen, do you have any updates?
Yeah, what I would say is thank you for your understanding. We, like Jamie said, just want to be cognizant of everyone's time and priorities today. So these have all been meaningful conversations, and we will be in contact with our other TPP speakers about fitting you in for tomorrow. Tomorrow with breakout rooms, what I would like to mention to everyone is I know that I've been in contact with our moderators and rapporteurs. Our moderators and rapporteurs for day 2 that were assigned to session 2, if you could still be available tomorrow, that would be great. If you have other obligations, please do let me know. Otherwise, for our participants, what we'll do is tomorrow in the breakout rooms, you will likely be able to choose which room you are going to unless you are otherwise noted as a moderator or rapporteur. So we look forward to having some meaningful discussions, and we appreciate everyone's presentations today, and we just want to be respectful of everyone's time. So thank you so very much to each of you.
So in conclusion for today, everybody, sorry again for the last minute changes and things. But you just kind of run up hard on deadlines. Thanks again for everyone's participation. We'll be back tomorrow, same time, and we'll be in touch with those who were going to present, Richard and Justus, about adjustments and things that we do to the agenda, and looking forward to figuring out these breakout sessions tomorrow. So thanks, and we'll see you tomorrow.
Great. Thanks, Jamie. And we'll see everyone tomorrow.
Yes, thank you.
Thank you. Bye-bye.
Bye.
See you tomorrow.
Bye bye from Mozambique.